So we're going to hit some of the harder type of problems you're going to see here. There's a huge variety of problems, and I'm sorry that 8.8 is just so long and difficult. Let's start out with something like this. You're multiplying something times a rational expression. If you're going to try and hope to simplify, the first thing you got to do is factor. Now, do yourself a favor. Let's write this, or think of this as being over 1. That way things can line up a little bit better. As far as factoring is concerned, the denominator should factor pretty easy. We just had a whole section on that. That would be 9c minus x and 9c plus x. How about the numerator here? Can anyone factor that one? No, it's going to be something and something else. Well, how about x plus 7 and x plus 1? And finally, the numerator here. Now that one's going to take a little bit more work. You might remember that if you have 4 terms, you should be thinking about what particular type of factorization. Grouping, yeah, definitely. So let's factor that one by grouping. And let's see here. From the first pair, I could factor out an x, which leaves behind an x plus 1. And from the second pair, I can factor out a negative 9c, which also leaves behind x plus 1. This is still all over 1. I got to finish factoring that. It's a 1 there. So to finish factoring that, I'll factor out the x plus 1.
And then x minus 9c.
Perfect. X minus 9c
Over 1.
over 1. Now, it's really easy to get tempted in doing something you can't here. You can't cancel from numerator to numerator. You can cancel from numerator to denominator. So let's do that much.
Don't you have to factor out a negative 1 to flip the signs to cancel out the x minus 9c?
Excellent. Yes, you do. I mean, that's one way you could do it. But yeah, if you look at these and you're like, yeah, I want to cancel these things, then you're kind of stuck because they're not exactly the same. But if you factor out a negative 1 from this, so let me factor out a negative 1 and I'll put it out front. Negative 1 times x plus 1. And when I factor out a negative 1, it's going to change the sign of both of these terms. So it'll leave me with a positive 9c and a minus x. So wow, we're going a long ways for just a little bit of cancellation here. Because the only thing that I see that you can cancel is the 9c minus x. Wow. Everything else is left there. Now we can write this a little bit more briefly because you have an x plus 1 times an x plus 1. So I'll leave the minus out front and I'll write x plus 1.
Squared?
Yeah, squared. Thank you so much. Over, or times x plus 7 over 9c plus x. So a lot of work for not a whole lot of return on that one. All right. Let's try some more here. Any other comments or thoughts on that one before I wrap it up on that one? Let's try a subtraction one. So we'll call this example B. And that would be 9x plus 8 over 5x plus 15 minus 5x minus 4, again, over 5x plus 15. So on the surface, this one's like, hey, great, we got common denominators. That's good to see. So all you have to do is subtract the numerators, right? But there's a place where people make mistakes on this one. And let me see if you can catch mine as I make it. I'll put the 5x plus 15 down here. I've got 9x plus 8 minus 5x minus 4. What's wrong with that? There is a mistake in here.
Is it because even though the two denominators are the same, it's still two of them, so is that supposed to be squared as the denominator?
That's a interesting thought. That's not the problem here. The denominators.
Distribute the minus and the 5x minus 4.
Yeah, there you go. Let's put a parenthesis around this, a parenthesis around this. If I want to get rid of that parenthesis, I've got to distribute it, and that makes this term negative, but that term positive. So by just leaving it the way I wrote it just a minute ago, I didn't have the signs all arranged right. So good job. 9x plus 8 minus 5x plus 4, distributing that negative sign. And that makes a world of difference in our problem, because without this having the correct sign, I would get this thing wrong. Let's see, that's going to leave behind 4x plus 12, right? Over 5x plus 15. Can I cancel the 4x into the 5x, or just cancel out the x's here? No, cannot. But what I can do is I can factor these. In the numerator, I can factor out a 4, which leaves behind x plus 3. What can I factor out in the denominator? 5x plus 3. Now I'm done, right? All done?
No.
Let's hope not. Let's hope you do, after all that work, I hope you do this last little bit here. Now, what's unfortunate about this problem is that if you mess up that negative sign here, if you have a minus 4 instead of a plus 4, this won't factor, you won't end up with the right answer. You're going to get 1 point instead of 4 points on a problem like this. So please be careful, all right? I'm telling you up front, I'm not trying to trick you. You will see a problem like this on your exam, and the goal is not to trick you, the goal is for you to get the 4/5 there, all right? Okay, let's try another one. On the last one, we were lucky enough to have common denominators. On this one, so example C, yeah, we're not going to start with common denominators. You're going to start with 6 over x squared minus 2x minus 3 minus x over 5x squared minus 13x minus 6. Ugh. Well, the first thing you need to do is factor each of these so that you can get a common denominator. Now I'll help you out over here, because this one's kind of a pain. That one's going to factor as 5x plus 2 times x minus 3. But how about this one? That one's an easier one. How does that one factor? Well, it has to be an x and an x. And because that is negative, one of these has to be positive, one has to be negative.
Is it 1 and 2?
Well, I have to multiply to 3.
3 and 1.
3 and 1, but which way am I going to put them in?
Negative 3. Oh,
Yeah.
positive 1.
Negative 3 and positive 1. Perfect. If you look at this, now we can determine what our LCD should be. Our LCD should have an x plus 1 term, an x minus 3 term, and a 5x plus 2 term. And I'm going to squeeze that in here, 5x plus 2. Sorry about that. So that's our LCD. Looking at this, I'm missing the 5x plus 2 term. So I'll multiply by 5x plus 2 over 5x plus 2. What am I missing here? That's part of my LCD. X plus 1. X plus 1. Now, I do something well, partly out of laziness, but partly to protect you. A lot of people are like, oh, hey, I can cancel this. That would put you back to where you started. We don't want to do that. So sometimes I'll just write LCD here. That way people don't feel like canceling here. And instead I'll distribute the 6. I get 30x plus 12. Here, I don't know, I'll leave the minus sign. We'll distribute the x, LCD. That would be x squared plus x. Kind of like the last one. You got to be careful. It's not a bad idea to put parentheses around that x squared plus x term, so that when I combine the like terms over the LCD, I'll remember to distribute that. It'll be minus x squared minus x. It distributes to both of those terms. And last but not least, we can combine like terms in the denominator. I'll put the minus x squared term out in front. But what's 30x minus x going to give me? That'd be 29x plus 12. When you're all done, neither WebAssign nor I would appreciate if you left it as LCD. Instead, we want to see 5x plus 2 times x plus 1 times x minus 3. So that should be in your final answer. You do not have to multiply it out. Just leave it as a product. Whew. That was a hard one. That was a hard one. Let's do
Can
an
we
easier one.
go back on that problem?
Yeah,
and
yeah,
go
please.
back to the part, can we go back to the part where we times the numerator and the denominator 5x plus 2?
Yes. So effectively, that's
That is
multiplying by
where I was at.
1, right? Because if something divided by itself is 1, but I multiplied that in the numerator and denominator so that I could get the lowest common denominator here. Because I've got 5x plus 2 times x plus 1 times x minus 3. That's exactly my LCD. So I got the LCD here, and then over here we looked at this and compared it to this and said, all right, well, I've got the 5x plus 2, got the x minus 3, I'm missing the x plus 1. So I multiplied by x plus 1 over x plus 1, and then x times that gave me this here. Again, over the LCD.
Gotcha, and that's where we got the 30x plus 12, because we had the times the 5 and the 6.
Exactly, you distributed that. And then you distribute there, you give me the 12. Nice.
Okay, thank you.
Yeah, good deal. Thanks for asking some questions. Let's do an easy one. Example D. 12x divided by y over 15xz divided by y squared. And again, I apologize that this early chapter just has like a lot of review stuff. There's not much of a way around it. It's trying to get you up to speed. But the thing that goes on here is that you've got one fraction in the numerator and one fraction in the denominator. That makes this a complex fraction. And when you divide by a fraction, does anyone remember the rule? What do you have to do when you divide by a fraction?
Multiply by the reciprocal.
Multiply by the reciprocal. Perfect. So reciprocal of this denominator here is going to be y squared over 15xz. You want to just do the cancellation right here? Sure. Let's take care of that right away. So let's see. What goes into both 12 and 15?
3.
3. So this can leave me with a 4 and a 5. And what else can cancel? Well,
The x's.
the x's cancel, so I can get rid of those.
The y's.
And one of the y's, correct? So I'll get rid of that. I'll leave a 1, and I'll just get rid of the squared. So, wow. I'm left with 4 times y over 5z.
Okay.
And that's it. That's all that's there. And let's see. Last one, example E. F of x is x squared plus 5x minus 24 over x squared minus 9. And there's two things that you're going to be asked for here. One is to simplify, and the second is the domain. And we'll actually start with the second of these first. As far as simplifying and the domain, both of them are going to require that we factor the numerator and denominator. So this is going to be an x and an x, x and an x. Can anyone help me factor the denominator? How would that factor?
X plus 3, x minus 3.
Nice. X plus 3, x minus 3. In the numerator, I'm looking for two numbers that multiply to negative 24 and add to 5. So negative 3 and 8, that would work. Now before you start canceling the 3, x minus 3 and x minus 3, let's think about the domain. The domain is associated with what value, what coordinate? The x or y coordinate?
X.
It's the x coordinate. Now, the x's that you can put in are going to be restricted a little bit by this thing in the denominator. You can't divide by what number? You can't divide by 0. So I want to know when x plus 3 times x minus 3, not x plus 3 twice, my bad. When x plus 3 times x minus 3 equals 0. For what values of x is that true? Well, you got something times something else equals 0. Either x plus 3 equals 0
X
or
equals 3.
x equals 3 or x equals negative 3.
0. Oh yeah, negative 3.
So your domain is everything but these values. So your domain is x not equal to 3 and x not equal to negative 3. If you were to put that on a number line, it would look like this. You'd have negative infinity to negative 3, negative 3 to 3, and 3 to infinity. So if they're going to ask you for this as a set of intervals, then this is the set of intervals that you would get. So a lot of work for the domain. As far as simplifying this function, that's pretty easy. Just cancel out those things. And you're left with, this is essentially an equivalent function to x plus 8 over x plus 3. And that'd be it. Awesome. All right. Last minute thoughts or comments on that one? Okay. Good luck with these. I'll walk around and help out. Please reach out if you need some help.